So I guess we can start. So thanks for coming. This is Introduction to Table Logic Programming with Picat. My name is Sergii Dymchenko, and there's URL of my website if you want to know more about me. So please install Picat if you haven't done so yet. You will need this. And also please go to this GitHub repository because it has PDF of the slides where you could click links easily, and also it has files you will need for exercises. So what's Picat? Picat is a new programming language, maybe, I don't know, 3 or 4, maybe 3 years old. So it's pretty similar to Prolog. And some syntactical constructs are the same for Picat and Prolog. And the main author of Picat is also creator of B-Prolog. And there's also a B-Prolog implementation that lives inside Picat. So it's pretty similar. And I could say that Picat is like more mainstream programmers friendly Prolog. And also it fixes some of the design issues with Prolog. It has many additional things, things that you can find in modern programming languages, like list comprehensions and hash tables and so on. So Picat is an acronym, and it stands for pattern matching, intuitive. It used to be imperative, but now they say it's intuitive. I don't know. For marketing reasons, probably, I don't know. Constraints, actors, and tabling. So this is all interesting stuff, especially constraints, but today we will focus on tabling, on the last item. But before we get to more interesting stuff like tabling, let's look at some basics of Picat syntax and how to use it. So I will use Emacs. You don't have to use Emacs. You can have anything. That's okay. So go to your terminal and run Picat. And you can use Picat in repo fashion. So, sorry?
Can you post the GitHub link again?
Yeah, sorry. Is it correct? I haven't verified. Yeah, this is important, so please download it. And also feel free to interrupt me anytime for questions. So let's continue with the repo. So it's Prolog style repo. You use queries. So like this. X equals 1. So it returns us very helpful answer that x indeed equals to 1, and it returns yes. It's like it was possible to find the answer. We can use something like this. And comma here is a conjunction. It's a conjunction of goals. What if we try to do x equals to 1 and equals to 2? It says no, because it's really not possible at the same time for x to be equal to 1 and to 2. But like we know in C++ or Java, it's possible. So it should be possible like in modern programming language like Picat. So we can do this. It's called destructive assignment. So it's similar to too imperative. It's basically an imperative construct, and you know it's bad. Don't use it if you don't need it, if you don't really need it. What else can we do?
Quick question, is it requiring capitals?
Yes, sorry. It's like Prolog. In Prolog and the Picat, all variables should start with a capital letter or with an underscore. So if you say x equals to 1, it will say no. Because x is a symbol. It's just x. It's not a variable.
Where's the period?
Period. You need to end your query with a full stop.
Okay.
So it's like, and if you use two different queries at the same. So when I said x equals to 1, after this query ends, there is no x.
So I was going to ask the same question because actually trying to without the period it's still random.
Okay, that's an artifact of REPL, so it tries to be helpful. So
Okay.
it just adds full stop for you, but it should be there. It's like in JavaScript, I
The
know.
syntax wants it, but it will fill
Yeah, it's for REPL. If you will use outside of the REPL, you will need full stop.
I see, okay.
Yeah, so, and when I ran x equals to 1, and after this query ends, there is no x. In different query, it will be completely different x, completely independent to the previous x. Also, we can do some arithmetic, like, yeah, really help. So there are also lists, like this. X is now a list. And you can put different things into a list. Like you can put 3 numbers and a symbol. There is also arrays. So lists are linked lists. So if you want to know a length of list, it will take linear time. If you know to get a specific element of a list, it will take linear time. So it's not supposed to be used in a random access data structure. So there is arrays. So like this. If you want to know length of array, it will be done in constant time. So we can do like this. So it says length of this array is 4. And you can also use len. And you can also use non-object-oriented notation. So here, object-oriented notation is just a syntactic sugar. It's not really an object. And also, we can create arrays of unbounded variable. So what's unbounded variable? So right now, these 2 variables are unbounded. So if you create an array of unbounded variables, it will look like this. New array, and you put your dimensions. Like if it's 2D array, 2 rows, 3 columns, it will be like this. So these names are just some randomly generated names for these variables. And they start with an underscore. It's a valid name for variable. And to access array elements, you can use this syntax. So see now one variable is bounded to 5. And Picat supports Prolog style non-determinism. So comma means conjunction and semicolon means disjunction. So if we say x equals to 1 or x equals to 2, it will return two answers. So the first answer is 1. And question marks means, do you want another answer? I want another answer. I press enter. Oops. No. Oops. I press semicolon. It means I want another answer. If I press enter, I don't want another answer. So there is possible to have like more than 2, of course. We can have like this. So. And there are predicates, undeterministic, non-deterministic predicates that return. These predicates can return several answers, like member. So basically, member assigns to its first parameter one of the members of the list. That is the second parameter. And to show you more syntax, I want to show you factorial. Picat also has built-in factorial function, but for learning purposes, for demo purposes, I will show you my own version. So there is no Picat mode for Emacs yet, so I use Eclipse, which is basically Prolog mode for this. It's not good for editing, but it's good for showing syntax structure. So this is factorial in Picat. Here we have two rules of the same predicate. And here predicate really is a function, but it's function means it's a special kind of predicate. So we have base rules, factorial of 0 equals 0, and we have our recursive rules. So f here means this is the return variable. We have the guard that n must be greater than 0. And we have this from definition of factorial. And this is tail recursive, and Picat has tail recursion optimization, so it works in linear time without allocation anything on stack. So how can we use this in our repo? We use CL, that means compile and load. Compile, load, and name of the file. So now it's compiled, and we can use it. Oops. Something wrong?
The base case wrong, factorial is 1.
Yeah, good catch. So let's fix it. Let's load it again. Yeah, so now it works. And just to show you the differences between Prolog and Picat, here is the same example in Prolog. So in Prolog you don't actually have functions, and you cannot pass this n-1 directly to your function. You need to introduce one more intermediate variable. So Picat looks nicer.
A question about the card you had on the previous slide. Could you feed it a potentially infinite list? Like, let's say
Yes, you can.
Yeah. Okay. And is it just like 1 ... for all the integers or something? Or all the natural numbers?
So there is a notation. There is a notation like this, but for infinite, I'm not sure if if you can do it with this notation. But you can introduce your own function that will just increment your number indefinitely.
Okay, so you have to have
I'm not sure about syntax. This will not work. So.
Can you think of this function syntax as like syntax sugar for the Prolog definition?
Yeah, it's syntax sugar for Picat predicate definition. It's nothing special. Yeah, it's just syntax sugar. And a little bit more syntax. Sorry, but I want to show you how to do loops. So this is a TPK algorithm that was proposed by Donald Knuth and Luis Pardo just to show syntax of language on a simple example. So this program is just reads 11 numbers, compute for each number its function, this just arbitrary function, and outputs in reverse order index and this number computed for input, or too large if this number is greater than 400. So this is the program. Now we are not going to use it in REPL. It will be run as script. So to run a script, you just define one predicate called main. So here we have our function definition. From TPK definition, it should be pretty straightforward. We have one variable. We read space-separated list of integers, of real numbers, and make it to array. So we transform list to array for faster access with index. And now we have for each loop. For each is like pretty similar to what you have in Python or something. So you have variable and you have list. And this list this means like start from n, end with 1, and step is -1. If your step is 1, you can omit the middle part. And this is if then else construct and printf, similar C++ or something. But we have a different specifier w, which means just print Prolog term. It can be anything. So how do I run this? Just from my terminal, I run Picat, TPK, just 11 numbers, and the output. So it's pretty straightforward, just to show you for each and if then else construct. And also actually, in recent version of Picat, you can use array comprehension. So you can use directly this. And it should be the same answer. Yeah, so now we know some syntax of Picat, and let's look at tabling. What is tabling? Tabling is just automatic memoization. It's not simple automatic memoization, but it's automatic memoization. And let's look at Fibonacci sequence. This is just straightforward definition of Fibonacci sequence. I think everybody should be familiar what Fibonacci sequence means. You just get sum of two previous numbers to get your next number. And this works, kinda. So let's try it. let's load it. And try Fibonacci of 10. Oops. So it kind of works. But if we will try like Fibonacci of 20, that's okay. Fibonacci of 30, it's like takes some time. Fibonacci of 35, it's even longer. And in Picat, we can use time to understand, to see how much time the call takes. So it takes almost a second, but let's try 40. Now it's taking some time. That's because this definition of Fibonacci sequence is, actually it has exponential running time. How can we make this from exponential running time into linear running time? Just add table at the beginning. That's all we need. And let's try reload this and 40 again. Now it's instantaneous. So this is like magic. Yeah, but this is really simple, like memoization of every value. You can write a wrapper in your language in Python or anything and to do this. But we can do more interesting stuff. This is called mode-directed tabling. Let me show you some example. So this is a very simple example. We have a predicate called sec, and it's non-deterministic predicate. It will return 1, 2, and 3. So 1, 2, and 3. But we can add more directed tabling specification. This means that from all possible answers, just choose the minimal one. Reload, run again. We have one answer, and it's 1. We can use max. We get 3. We can use just table. What do you think it will return? Just table. So just table will return the first answer. So it will be 1 in our case. Oops. Something wrong. No, it will return all answers because it's for the same, it's different answers. Sorry, I'm a little bit, was a little bit wrong with this. So just think about, we can put here min or max. Just don't think about just table for this particular example. Why are we interested in mode-directed tabling? Because we can use it for easily and declaratively solving dynamic programming problems. So let's see at one example. It's a problem we created for a programming competition last year. It's called Levenstein distant, but it's like modified Levenstein distant. You have 2 strings, and you want to figure out the best way to transform one string to another string. And operations you can do substitution. And substitution, the cost of the substitution is difference between positions of these letters, of letters you substitute. So if you substitute A for A, the cost will be 0. If you substitute A for B, the cost will be 1, and so on. You can also insert or delete a letter from a string. And the cost for this is, again, index of this letter in the English alphabet. So this is basically a very, very basic and classical dynamic programming problem. And I want to show you how to solve it in Picat. So at the bottom we have end, we have main, and main just reads two strings from the input. Here we have global map, and this is just Picat way to get global variables. So in dynamic programming we have state. State changes from one iteration to another. And our input is not really part of the state. We want it to be global for every step. So one of the ways to do this in Picat, put it in global map. This is key. This is value. So basically, this is a way to put this input into our predicate that will be solving this. And we run edit. Edit is our predicate. And output the distance, the minimum cost of transforming one string to another. And here we have mod directed table definition. So it means plus means input. So this predicate has 3 parameters. First 2 are input, and the third one is output parameter that we need to minimize. So that's the meaning of this table definition. So at the beginning we just get global string and goal into our local variables. We get length of the strings into n variable and m variable. And here we have basically the meat of this predicate. This is conjunction. So we have 4 possible different outcomes, 4 possible different actions we can do. The last one is just a base case. So what is the state for this problem? So I is an index. The first parameter I is an index of the S string we want to look next. The second parameter is index inside the second string we want to look next. So basically, we want to move our indices into 2 strings, and when we get to the end, it means we change one string into another. So the last parameter means if the last clause means if our first parameter is greater than n, it means that we already looked and uncounted for each character in the first string. And also, the second parameter is greater than m. We did that for the second string. The distance is 0. Otherwise, we have 3 more interesting cases. First case means that we haven't finished any of the strings yet. And we have recursive call for edit distance for the next part of the strings. This is basically substitution. So cost of this substitution will be this, or it means ASCII code of the character. So if this will be A and this will be B, differences between ASCII codes will be 1. The second clause is deletion from the first string. The third clause is deletion from the last string. And we recursively call our edit function with the rest of the strings. So I think this is maybe a little bit too confusing, but if you're familiar with dynamic programming problems, it should be more clear for you. If not, please look how to solve edit distance with dynamic programming.
What is the zero?
Sorry, 0, it just means ASCII code of A. So if this will be B, so we want to know number of letter in English alphabet. If this will be B minus ASCII code of A, it will be 1, and so on. So let's try to run it. Let's transform A to A. The cost is 0. Okay. The cost is 2 because we need to add 2 A's or remove 2 A's from the first string or add 2 A's to the second string.
Can you remind me what does the function do? What the distance that we're trying to measure?
This is an edit distance for programming competition. It doesn't really have some practical meaning. So we want to understand what is the minimal cost of transforming one string to another, and the cost definition is it depends on letters. Huh?
It depends on the difference between each letter.
Yeah, it depends on difference between each letter, or if we delete letters or add letters, it depends on the index of that letter in English alphabet. It's like it doesn't have any practical.
We don't really understand the function, so we don't see.
Okay, yeah. So this is basically the definition.
It's useful for detecting spelling errors and things like that.
Yes, but if you want to detect spelling errors, you don't probably want like difference in English alphabet. You want probably difference in like keyboard distance or something. Yeah.
The other question I have is it possible to lexically scope string and row instead of putting them in row?
Yes, we can. No, it's not possible to lexically scope. The other solutions is just pass it as a parameter. One more solution is to create a prolog fact, like just to commit to fact database. So
tabling has to happen at the top level.
yeah, tabling is, this table definition is for this function, for this predicate.
Function definition has to happen at the top level.
Yes. There is no lexical scoping.
When you use min or max,
Uh-huh.
mode-directed tabling, internally, does it have to then exhaustively go through all possible?
No, it's really pretty clever mechanism. I don't really understand it. It's like consume sub goals, and there are papers about it, a lot of papers. It's like it's done in a clever and efficient way. So now I have a simpler dynamic programming problem, and I want you to complete my step. So basically the problem is that we have a number of coin values. For example, we have coins 1 cent, coins 3 cent, and coins 5 cent. We have possible nominations, possible values. And we have a sum. And we want to find the minimum number of coins that can sum to this number. So yeah, for example, if you have values 1, 3, 5, and target sum is 13, the answer is 3. Take 5, 5, and 3. And I created a file. It's not complete, but it should be easy to complete. So in main we just read possible values. Use this ugly global map to pass it to our method. Read target sum. And if it's possible to do this, we output count, number of coins we used. Otherwise, we output impossible. And this is what I want you to complete. So feel free to use documentation, or if you're stuck, just raise your hand and I'll come to you and help you.
You have a missing closing right after the coins. I think you're supposed to be closing at random
Yes.
coins, yeah, so each random coins.
Yes.
So a hint here, you probably need to use member predicate. If someone completed this, you can also, for a challenge, output also nominations, like actual coins you used, not only the number of coins. I wonder if someone completed it. Raise your hand if you finished. Okay. Are you trying to debug?
Yeah, is there a tracer? Yeah, you can debug.
So this outputs it for table declaration. So basically you define tables for one parameter variable. This is written to be run from command line. So we just use leave the Python repo and just use terminal Picat and the name of the file.
And also plus and so is this like
Yes. Because you only can minimize output parameters.
Sure.
Actual points, like for the example 15, it will be 5, 5, and 3. So if you go for the challenge to output actual values, you will need to know how to add stuff to a list. So the syntax is the same as in Prolog. Like this. Head, tail separated by vertical bar. Yeah, so I think a lot of people have done the exercise or almost done, so I'll show you how I'm going to do this. So table definition is pretty simple. We have two parameters. The first one is input parameter, and the second one we want to minimize. And here we want to use member to get a coin from possible values. It will do this in non-deterministic way. It will try all variables.
Reduce all possible now.
Thank you. And we want to make sure that coin is less than equal to sum, because it doesn't make sense to get coin if our target sum is more than value of the coin. And we recursively call our coins predicate with new sum. And new sum is basically old sum minus coin value. And here we need to introduce one more variable, like next count, for example. And our actual count will be next count plus 1. So this should work. Let's try it. Yeah, so it looks like it works, so I didn't make a mistake. So for the challenge, if you want to output actual values, I have this program. So you want to minimize the second parameter, but your third parameter is just output. And for zero sum, your value is just an empty list. And for the different case, you just prepend your coin to the values. And you need to print it somewhere. So I think let's have a break. Let's return in 10 minutes. Caching, but it's kind of, I don't know, the different ways to take. Picat does some things called lunatic. It has some low consumption. I don't really know a lot about it. There are several papers how it's not compiled one time, it's caching, but it's kind of clever way. Yeah, but if you do compile time, you need to ask. It's kind of two-stage runtime. Yeah, you can like make a Picat program that will generate different Picat values. Yeah, for example, for Fibonacci, we don't know for what values you are going. Picat has big integers, so technically you can put million or Google. So for which values do you compile? На этом Picat получается проще, как бы пишешь рекурсивно, сейчас рекурсивно проще кидаться.
Необычно решение, потому что рекурсивно,
that makes things really difficult. So I'm actually really
you will get where the first one is.
it's like,
And
Yeah, it's like the thing. Is it another very compared class that just has some, and they refuse to get rid of like the sheep. So even though it's like far away, say this, like